Okay, we prove the theorem if f is the gradient, if f is the gradient of some scalar phi, that is f equal to grad phi for some scalar phi, for some scalar phi, then the line integral f dot dr is independent of path, then the line integral f dot dr is independent of path joining any two point and vice versa. Let's prove it. So we assume f is gradient of phi. Let's assume for a given vector field f, comma, there exists a scalar phi such that f equal to grad phi. Okay, then for any two fixed point a comma b, then for any two fixed points a comma b, integral from a to b f dot dr equal to integral from a to b grad phi dot dr. Also, we know grad phi equal to partial derivative of phi with respect to x partial derivative of phi with respect to y, partial derivative of phi with respect to z. These are the components of del phi. Grad phi is del phi del x I plus del phi del y j plus del phi del z k, and dr is your dxi plus dyj plus dzk. If we take those two dot product, then we will get gradient of phi dot dr is del phi del x dx, I dot I is 1, I dot j is 0, del phi del y dy, del phi del z dz. Del phi del x dx plus del phi del y dy plus del phi del z dz. Now we can write this grad phi dot dr here. Of course, before writing that, you also know that this is nothing for d phi. So you better write just d phi here. Grad phi dot dr is d phi. This implies integral a to b f dot dr, that we have equal to a to b grad phi dot dr, but that's just d phi. Grad phi dot dr is just d phi. And so that is phi evaluated at the point B minus phi evaluated at the point A. So it only matters what are those points. And so A to B, we have d phi, and that is phi evaluated B minus phi evaluated A. So what matters is what is the end point and what is the final point. It doesn't matter what is the path that you have taken. So we can say line integral is independent path between A and B. So A to B f dot dr is independent of path between A and B.